This is lesson 3.2, solve two-step equations. You should be on page 141. You'll notice I don't have a picture of the book today, and the reason I don't have a picture for the book on this video, there isn't any vocabulary. The best way I can teach you how to solve two-step equation is just to show you examples. And I didn't want to just copy down the book examples, so I figured we could do some from the book, and you can see what we need to do. So let's talk about solving two-step equations. When you solve two-step equations, what it means is we're going to use two separate inverse operations to solve the equation. Now, you learned inverse operations in the last lesson meant, like, for example, the inverse of adding is subtracting, or the inverse of dividing is multiplying, okay? We're going to have to use two separate inverse operations to solve these kind of problems. So if you go to the bottom of page 141, you look in the bottom left-hand corner, do you see a question that says 5x plus 9 equals 24? We're going to solve that. Now, to solve that, we want to keep three things in mind. The first thing we always want to do when we try to solve an equation is always try to simplify it, which means combine like terms on each side of the equation if you can. Let's try to simplify. Well, can we combine 5x and 9 together? I hope you're sitting there saying, no, Mr. Lemansky, we can't because these are not like terms. You're correct, we can't. And 24 is already simplified. So we tried to simplify, but there's nothing to simplify here. So we go on to step 2. We want to use inverse operations to isolate the variable. Now, I don't know if you've heard of this before. I like teaching this. When you solve an equation, you want to treat it like an onion. Think about the center of an onion. To get to the center of the onion, does it make sense you have to peel away layers? I think you've probably all seen an onion. Onions have layers. If you want to get to the center, you'd peel away the layers. So treat an equation like layers. So I'm going to draw with a blue pen. I'm going to draw an onion. Now the center of the onion is always the variable. There's the center of my onion. What's the next closest thing to the variable? It's this 5. That's the next layer of my onion. The plus 9 would be the outside layer of the onion. So I want to peel away the onion, and I want to get to x. Well, to peel away the onion, I got to get rid of the outside layer first, and you see how the outside layer has this plus 9. So mathematically, what would you do to get rid of plus 9? I hope you're saying to yourself, well, I'd have to subtract 9. So do that first. If you subtract 9 from each side of the problem, that's the subtraction property of equality, that would force this outside layer to be peeled away, and you'll have 5x on the left, and 24 minus 9 is 15 on the right. Next step, okay, we got to peel away the next layer of the onion. There's the inside layer, there's the next layer. I got to get rid of this next layer. Can you see how x is being multiplied by 5? So to get rid of the next layer, I have to get rid of the multiply by 5. Well, how would I get rid of multiply by 5? I hope you're sitting there saying, oh, Mr. Lemansky, I would divide by 5. So that's correct. Divide each side by 5. Now you're peeling away that next layer, and now we finally got to the center of the onion. It's x. Well, on the other side, 15 divided by 5 would be 3. There is the answer to the problem. So we use two different inverse operations to isolate the variable. My first inverse operation, I'll write these in green. Here's my first one. We subtracted 9 from each side. We used the subtraction property of equality. The second inverse operation was right here. We divided each side by 5. Can you see two inverse operations? Now, when you get your answer, quiz, test, or whatever, you should always get these right. You should check your answers. Let's check. And you can use your calculator when you check. Take 3, go up here, and plug it in using your calculator. So in your calculator, you should do 5 times 3 plus 9. Double check. Does this give you 24 because it's supposed to give you 24. If it does, you know the answer is correct. If it doesn't work, that means you made a mistake somewhere. Don't leave that answer. Figure out where your mistake is and retry the problem. On a quiz or test, I can always tell if you checked your work. If you have the wrong answer, I normally will write on a quiz or test, did you check this? Because if you did, you would have found out it's wrong, and let's be honest, no one's going to leave it wrong if they know no one's going to leave that answer if they know it's wrong. You're going to change it, okay? Let's do another one. Still on the bottom of page 141, do you see this question? 4y minus 4 equals 16. So first step, do we have like terms? Let's simplify if we can. Well, I'm looking on the left. I cannot subtract these. They're not alike. 16 is already simplified. So I tried to simplify. There's nothing to simplify. So step 2, inverse operations. Let's think of our onion. Here's the center. The times 4 is the next layer. The outside layer is a minus 4. I want to peel away from outside in. So to get this outside layer peeled away, what's the inverse of minus 4? Well, I hope you're sitting there saying, well, add 4. Okay, so adding 4 will peel away this first layer. So minus 4 plus 4 cancel. I get 4y on the left. I get 20 on the right. Okay, let me draw up my onion again. Here's the center. This times 4 is the next layer. I got to get rid of that times 4. I hope you're thinking, well, the inverse of times is divide. So let's divide each side by 4. And I'm going to get y equals 5. Okay, let's check our answer. Let's verify that this is actually right. So take your calculator and you're going to go right back to the beginning. You're going to type in 4 times 5 minus 4, and you want to double check that you're getting 16 out of that. And yes, we do. Okay? Let's do another one. Bottom right of page 141. Here's my equation. Let's try to simplify. Well, negative 1 I can't simplify. Over here, these are not alike. I can't simplify. You always want to try to simplify first. Okay? Well, let's go to our inverse operations. Let me draw my onion. Z is the center. The divide by 3 is the next layer. The outside layer of my onion is the minus 7. Sorry, my pen isn't responding well. So let's solve this now. The outside layer is minus 7. How do I get rid of minus 7? Well, the inverse is to add 7. So I'm adding 7 to the right, and I'm adding 7 to the left. Minus 7 plus 7 cancel. I get 6 on the left, and I have z divided by 3 on the right. Let me draw up my onion again now. So here's the center. The divide by 3 is the next layer. I have to get rid of the divide by 3. That's the next layer to peel away. So how do you get rid of divide by 3? Well, I hope you're saying, Mr. Lemansky, just multiply by 3. So I'm timesing by 3 on the left and the right. That's called the multiplication property of equality. So divide by 3 times 3 cancel. I get z on the right. And on the left, 6 times 3 is 18. So I think my answer is z equals 18. Let's check. Okay, we should always check. Let's take 18 and plug it in. So in my calculator, I'm going to take 18, I'm going to divide that amount by 3, and then subtract 7. And I want to make sure that when I do all this, I get negative 1. And if you do that, you're finding out, yes, it does give me negative 1. Turn the page to 142. Look at the bottom. You'll see some more questions. We've got a few more just to try, just to make sure you got this down. Let's solve this problem. The first step, can we simplify? Well, let's check. Well, I can't simplify 24, but look over here. Are these alike? I hope you're saying, oh, yes, they are. Well, let's simplify these. 4w plus 2w can be added together. It becomes 6w. This is why you always want to check and simplify first, because you notice this is going to be easy to solve now. You always simplify first. Now, let's use the inverse operations. There's the center of my onion. There's the next layer. I got to get rid of that 6. This is times 6. I got to divide by 6 to get rid of that times 6. Divide, W equals 24 divided by 6 equals 4. Let's check our answer. Now to check, you're going to take your calculator, you're going to do 4 times 4 plus 2 times 4, and you're going to make sure that when you do 4 times 4 plus 2 times 4, you want to make sure that this actually works out to 24, and when you plug that in, it does. Okay? Let's do one more. Okay, I want to solve this. Step 1, let's try to simplify. Well, I can't simplify negative 16, but oh, look at over here. I have like terms. Let me add the opposite. 5d plus negative 9d is negative 4d. So I have negative 16 on the left, and I have negative 4d on the right. Let me draw up my onion now. D is the center. Times negative 4 is the next layer. I'm multiplying negative 4 and d together. So how do I get rid of multiplication? I hope you're saying division. I got to divide each side by negative 4. Okay? So divide, and d on the right would equal negative 16 divided by negative 4 is 4. So d equals 4. Okay, let me check my answer. To take my calculator. Now this was the original problem. Let me erase it to what it was. That was the original statement right here. We're going to do 5 times 4 minus 9 times 4. And we want to make sure that when we do this, we get negative 16. Check that on your calculator. You do. Okay? Now, we will show our work. Okay? And let me just write that in here. So you will show work as modeled on this video. When I grade your work, like if I was grading this problem here, I typically grade the problem as worth 3 points. Okay? Now here's how I grade the 3 points. It's 1 point for the answer. It's 2 points for the work. Okay? So if you just want to write the right answer down, I'll give you a point. But if you want all 3 points, I want to see the work. I'm not going to write this on the video, so I hope you're listening and not just forwarding slide by slide. You do not have to draw the onion. I am just drawing the onion on the video so you can see on every problem I am working outside in. If you work outside in, you will get these done right. If you do not work outside in, you will screw these up because you have to do it in the right order. It has to do with the please excuse my dear Aunt Sally. You must do problems in the right order. So that's why I'm drawing the onion, to try to show you I'm going in the right order from outside in. A couple more things and we're done. You will have problems like if you look at the bottom of page 42, number 7, they will ask you to solve these questions too. It says the output of a function is 5 more than negative 2 times the input. Find the input when the output is 11. So let's write that out. The output is 5 more than. So this is what that means. We are adding 5. 5 more than means add 5. To negative 2 times the input. Do we all remember that input means X and output is Y? So the output is 5 more than negative 2 times the input. There's my equation. Now, it says find the input. So find X when the output is 11. So in other words, they're saying put an 11 in here for the output. So they want me to solve 11 equals negative 2X plus 5. Okay, let's try to simplify. I can't simplify 11, and those are not alike. I tried simplifying. I can't. I'm going to draw my onion up so I get the right order. Now, again, you don't have to do this on your homework, but I think it's a good visual for my video. Okay, I got to get rid of the outside layer of the onion first. I got to peel from outside in. I got to get rid of plus 5. So take away the 5 first. Those cancel. I have 6 on the left, and I have negative 2 times x on the right. Let me draw up my onion again. There's my onion. I got to get rid of the next layer, which is the times negative 2, because we're multiplying negative 2 and x. So divide each side by negative 2. Negative 2's cancel. I have x equals 6 divided by 2 is negative 3. So my answer is x equals negative 3, and you should check it. Take negative 2 times negative 3 plus 5 in your calculator and verify that it's going to give you 11. Okay? Last thing, and I'm going to pause the video. You will also have to do word problems. Okay? Look on the bottom of page 143, and you'll see at the very bottom it says Kim has a job where she makes $8 per hour plus tips. Yesterday she made $53, 13 of which are from tips. How many hours did she work? So let me write this out in words first. Kim's pay equals her hourly pay plus tips. Okay? Now, her pay was $53. She got $8 times the number of hours she worked. I'll use H for hours. And it says here she got $13 in tips. How many hours did she work? So there's my equation. Well, let's peel the onion away. So first of all, time out. Before I peel the onion away, can I simplify? Well, nothing I can do here, and there's no like terms here. So I should always check. I can't. Now it's onion time. There's the center of my onion. The times 8's the next layer. The outside layer is the plus 13. We need to take away 13 first. And I get 40 on the left. 53 minus 13 is 40. And I have 8H on the right. So let me redraw my onion again. There's the center. The times 8's the next layer. I got to get rid of times 8, so I'm dividing by 8. And I'm getting H equals 5. So the answer must be 5 hours. Let's check. Take your calculator and take 8 times 5 plus 13. Make sure you get 53. You do. Okay? That's where I'm going to pause the video. If you have questions, make sure you ask in class.